Hi. In this video, we'll try to study about the arrays used in C programming. Remember, arrays are a specific type of data storage structure in C, which is very widely used in embedded system application. So it is very important for us to have a clear understanding of array as well as pointers before we move forward. So in this video, we'll try to study about array, probably do some exercises in this and the next video, and then we'll try to study about pointers. So let's get started. What exactly is an array meant by? Now you are doing programming and you are specifying some variables, like let's say you're specifying int a and then you are storing some number into it. Or if you are working on characters, then or alphabetical letters, then what you can do is you can specify a character like this, character B, and you can store a letter into it. But when you have to store more individual numbers together means what exactly? Try to understand the concept. So I don't want to just save 24, but I want to save 24, I want to save 12, I want to save 15. It doesn't matter what those numbers are, just like that. Or I don't want to save a single letter. Instead, if I have to save an entire string like that, so hello world. If I have to do such kind of application, if I have to store such kind of data, let's say when it comes to number, then you want to create a particular matrix kind of thing, which is what we call as array of numbers or array of characters. Now, whenever you want to do any such kind of operation, whenever you want to save multiple things, multiple numbers or multiple data with just one variable, then what we do is we make use of array. Now, array is basically collection of data. Just consider this like this simple opening and closing square bracket. And if there are a number of different numbers into it, then this is an array. And that entire thing is allotted, or that entire construction of all the numbers combinedly are allocated to a single variable. For example, let's say A may consist of this, or B may consist of hello world. Both of them are actually array. There is a small difference which we'll discuss later on. First of all, this is an array of numbers and this is a collection of alphabets, although it is also treated as array in C programming. Now let's try to see how we can define these arrays. There is no special treatment or there is no special method of defining array. What you need to do is we need to simply specify it like this. So int a, specify a square bracket, and let's say what's the size of array a that you want to have. So you can simply declare a50, means what? A can store as much as 50 values, and each value can be int. It means each int value, or a is nothing but a collection of 50 unsigned int values, signed int values. Similarly, you can write down unsigned int, let's say b of 20. What it means is b can be a collection of 20 unsigned integers. When you initialize it, you can store the numbers like this. So b is equal to opening square bracket, and whatever numbers you want to write, you can write those numbers. Remember, an array can only have single data type or single type of data into it. Means if your b is a integer array, then you can only store integer values into it and not the float values. It will create an error. You can create an array like this, you can store values like this, and you can access every individual value like this, which is called as indexing. So let's say if I want to access this first value, I'll just make it 120 to avoid confusion. So I just want to access, let's say 20. Then how do I access it? 20 is accessed as b of 0, or 10 is accessed as b of 1. This is called as array indexing. As simple as that. 120 will be accessed or addressed as b of 2. Similarly, every character in an array has an address position which starts from 0, 1, 2, 3, 4, 5, and this is sixth element in your array. Now this is all theoretical discussion about array. Let's try to see something practically. Now I'll just open our coding software that we use, code blocks, and we'll create a program into it. Let me call it array 0 because we're just trying it out. Okay, we're not doing any programs into it, we're just checking for it. This is very important, so please go through the video completely, guys. I'll be showing all the different examples in the same video. So code blocks is open. Let's go to file and new empty file. Let me save it as array underscore 0. Array underscore 0 will tell you the first program of array discussion and so on. So let's save it, and now let's try to write some code. So hash include stdio.h. Let's just zoom it a bit so it's good for you. Next is void main and opening closing bracket. Now this is your normal integer value, or to be precise, unsigned. As I told you, we are studying the C programming from embedded systems point of view. Therefore, it is always better to keep unsigned before your variable name if you don't want to use signed number. So unsigned int a is equal to that something. However, if I don't want a to be a single variable and if I want a to be an array, the way to discuss or the way to initialize the array is like this. So you will write it down like this. So unsigned int a, let's say, is a collection of 10 values, is equal to, open a curly bracket. In here, in theoretical discussion, I just showed you with a square bracket because it's easier for understanding. In programming, the syntax is to use a curly bracket, opening and closing curly bracket, and then specify whatever values you want to store into it. So let's say 101, 51, 71, 99, 85, 76. I am giving less than 10 values because here you specify the maximum number of values that you want to store into the array. This is just a definition because whenever you do this, 10 locations will be reserved for this array. It doesn't mean that you cannot store more than 10 locations, but this is just an initialization kind of thing. Let's give it a try. So this is what an array declaration looks like. And now let us assume that I want to print 51 and 99. Let's see how I do that. So for that say, what I'll do is I'll just print a new line. I'll just keep it as it is here, which will act as a separator whenever we are printing something. Nothing, it just doesn't serve any purpose. It just makes our output look differentiated than the rest of the command prompt window. Now what I'll do is I'll print the 51. I'll try to print 51. How? Let's see. Printf %d, comma, as I said, you need to tell the, or you need to write the name of variable, then open a square bracket, close a square bracket, and then specify the index. So for me, 51 lies at index number 1. So I'll just specify index number 1 here and then give a semicolon. Let's give it a try how it works. So build and run. Okay, my mistake. So semicolons are missing. Build and run. Now you can see 51 is printed onto terminal or the output window because we printed a of 1. If I print a of 0, that will give me 101, right? If I print a of 2, that will give me, or a of 3, that will give me 99, right? Now you can also modify a particular variable. Let's say I want to store the addition of 51 and 99 as a of 0. How do you do that? So let's see. So a of 0 is equal to a of 1 plus a of 3. Okay. And now let's try to print it. So I'll just keep this line commented for you to refer later on. And then print a of 0. So 51 plus 99 should be 150. Let's see if we print 150 as a result of this addition. We'll just also write it down as addition is %d, or addition is %d. Fine. See, addition is 150. Now if you want, you can also specify the numbers into it. So addition of %d and or plus symbol %d is equal to %d, comma a of 1, comma a of 3, comma a of 0. So this is where I want to print the first number, second number, and here I want to print the result, which is stored in a of 0. Let's try to run this code. So addition of 51 plus 99 is 150. Got it? I hope this should be clear to you. I would say please give it a try. Try to make such kind of experiment. Try to access different elements of your array before pushing forward or before going to the next topic. In next topic, we'll see how we can use a for loop to iterate over these array elements and do something with it. So try. Hi there. Now that we have discussed about arrays, I have two different programs to show you for trying out. So I would suggest you to please understand the problem statement first, then pause the video and try to solve this program by yourself. And if you do face difficulty or if you cannot solve it at all, then continue with the video and see for the output. So the first program is finding largest number in an array. Now what we need to do in this program is we need to scan some numbers and then store them in an array and then find out the largest one. So let me describe the problem statement once here. So I'll just write a comment. I'll save it as array largest. The problem statement is scan 6 numbers and store in an array and then print the largest one out of them. That's the problem statement. So please pause this video for now and see if you can do it. All you need to do is use an array, use a for loop and try to do something with it. So just wait here, pause the video now and try to do it on yourself. Now if you have done this program or if you were not able to do this program, please see forward how we solve this. Now I could have given you the program itself just to check, but I also wanted to show you how to solve a problem statement or how to break down a problem statement to get an answer. So therefore I am going to solve this problem in front of you so that you can understand it better. Now see, the first problem statement here is scanning the number and the second problem statement is finding largest. Now for scanning the number itself, what we are going to use? We are going to use for loop and we are going to use scanf function. And similarly, for finding largest number, we are going to use for loop. And inside for loop, we will have to use the if condition to find out the largest or not. Now let's see how the logic can be built for it. So get started with hash include stdio.h. Then void main. Then let's declare an array. So a of let's say 10, where I'm going to store the numbers. Let me make it unsigned. Then let me take two more variables I, j, just to create our for loop. And then let me take another variable unsigned int largest. This is to store the largest number into a variable. Now first problem statement is to scan 6 numbers. So what we'll need to do for that is for I equal to 0, I less than 6, I plus plus. So this for loop will execute 6 times. Before that, what I'll do is I'll just printf. So printf /n/n, enter 6 numbers one by one. This is just to make the program readable. Now let's try to scan them. So scanf %d, comma, %a of I. Means whatever number is received, that will be stored in an array I, starting from location 0, 1, 2, 3, 4, 5. So all the numbers will be scanned in this format. So after this, the array has been scanned completely. Now let me printf array scanning is done. Now the next problem statement is finding out the largest number out of that array. Now for that sake, what I'll do is I will again try to use a for loop. Now let's see how to do that. Before I tried the for loop, what I'll do is I'll do this: largest is equal to a of 0. I know a of 0 is not the largest number, or we don't know about it, but we are initializing with the first value, that is the 0th value of our array. Now the for loop will go like this. So for I equal to 0, I is less than 6, I plus plus. And here now I'll write down, if largest is less than a of I, it means what? If our largest variable value is less than a of I, in this case a of 0, the first value, then largest equal to a of I. Means if the current largest value is less than the value which is being compared with, then we replace or we place the value in largest variable. What basically it means is, if the largest variable is currently greater than a of 0 or a of 1 or a of 2 or whatever numbers, then there is no change. But if this number is less than this number, then this number will be copied into largest. That's all we have to do. Now what will happen is, this loop will continue first time when you compare it with when I is 0. They both are equal because we are starting with largest is equal to a of 0. So no action is taken. Largest will still consist of value of a of 0. Next time what will happen? Largest will be compared with a of 1. Now if largest is smaller than a of 1, then the a of 1 will be stored in largest and the next iteration will continue. Similarly, next time largest will be compared with a of 2. Now if a of 2 is smaller than largest, no action is done. But if it is larger, then it will be replaced and the value will be stored in largest. By the end of this entire for loop, what will happen? We will get the largest number in variable variable largest. The largest number of array is %d, largest. I hope the logic is clear to you. Let's save this program and let's try to run this. You will have to do, again a note from me, you will have to do this kind of programming many times in embedded systems. So please be sure about it to exercise these programs on your own instead of directly looking at the solutions. So let's run this code. Enter 6 numbers one by one: 65, 35, 95, 854 and let's say 154, and I'll hit enter. One more number is remaining. Array scanning is done. The largest number of array is 854. You got the right answer? Let's try it one more time. So let's scan 6 numbers one by one. I'll give larger number: 1025, 3052, 6521, 9585, 7542, 65437. The largest number is 6584487. Got it? Now once you have understood about this largest number program, even if you have not written it first, now stop the program, don't copy it from the library and try to do this program on your own. I hope you will be able to enjoy this exercise and also you will be able to do it afterwards. So try out this program and we'll see one more program in our next video. Thank you for watching. We are discussing array programming in C language from embedded system perspective, and in the last video you have seen this simple program where you can create an array and probably try to access the elements of it, modify the elements of the array in this fashion. Now what I am going to try now is I will take a new file. I will save it as array_1, and here what we will do is we will try to get some numbers from the user and store it in an array. So let's consider the problem statement like this. So scan 5 numbers from user and store it in an array. And once you do this, try to print those numbers. Okay. Now in this case, what I'm going to do is I'm not going to I'm not going to create the array directly as we did in last video. Instead, we will accept the numbers from the user and then we'll try to formulate an array with it. So let's begin. Hash include stdio.h. This is very important, guys. Every time in embedded systems application, you will struggle at array if you don't undergo the exact understanding of array, or if you don't clarify the exact understanding of arrays. So void main. Then let's create an array of let's say 10 elements. I don't initialize it here. What I'll do is I'll just call it unsigned int. Then I'll have another unsigned int I, because I want to accept 5 numbers, and the best way to do that is using a for loop, of course. Now let's print to the user. Okay, print f /n/n. That's a very nice actually line to copy paste every time. And then I'll print f. Enter 5 numbers one after another and /n. Now what we need to do is scanf %d and comma ampersand a variable. So we specify it like that. So ampersand a, b, c or something like that. Here you have to take 5 numbers. Forget about 5 numbers. Let's say we are taking just one number first. So I will accept it like this, a of 0. And then we'll print the scanned number is %d and a of 0. Let's just give it a try if it works or not, and then we'll convert it to accept 5 numbers. So my first number is 54. The scanned number is 54. It works. Now how do you make it work in a for loop? What happens is in a for loop you have an extra variable like I, which you can use for the indexing purpose. So let me show you how it works. At this point what I'll do is I will start a for loop. So for I equal to 0, I less than 4, I plus plus. Means I will start from 0. I will increment 0, 1, 2, 3, 4. After 4 it will become 5. For loop will be broken. Now in this for loop what I will do is I will do scanf %d comma ampersand a of I. Again, if you specify just some number like 0, 1 here, what will happen? All 5 numbers will be stored one after another in the same location, which we don't want. We want every location to be stored in a different place, just like this. So what you exactly are willing to do here is you want to have a variable a. Okay, a is like a stack or rack. Now you want to store 5 numbers into it. So those 5 numbers are expected to be stored first at 0 location, then 1 location, then 2 location, then 3 location, and then the last one at location number 4. So you want to do that. Numbers or data should be stored at a of 0, a of 1, a of 2, and so on. Now to do that, what we do is we create the for loop just like what I have shown here. Now just look at the code and try to comprehend what it is doing. If I specify a of I here, what will happen the very first time? For loop will be executed, value of I is 0. So scanf will be executed, a number will be taken from the user and it will be stored in a of I. Now value of I is 0 here. So in the first iteration, it will be stored in a of 0. In next iteration, it will be stored in a of 1. In third time, it will be stored in a of 2, a of 3, a of 4. It simply doesn't matter. Whatever number of times your for loop is going to execute, your code will execute. Now let's try to see if it works. Now to check if it works or not, what we will do is we will try to print all those numbers in a sophisticated manner, like just like a matrix. Okay. So we'll just call it here %d, comma, %d, comma, space, %d, comma, space, %d, comma, space, %d. So this is how I will be printing this number later on, and I'll just pass all the numbers. Now we can do the printing also using for loop, which I will show you later on. First, let's try it out. Okay, everything can be done, but just be patient. We'll just try something out first. Done. Now let's try to run this code. Enter 5 numbers one after another. I'll take first number as 11, 22, 33. Let me zoom it in. 44. Sorry, 33. Enter. 44. Enter. Sorry. I'm really sorry. I just did it too fast. It should be I less than 5. Only 4 numbers are accepted. If you do it I less than 5, then 5 numbers will be accepted. Now I'll do it slowly. 11, 22, 33, 44, 55 and enter. Now see, these 5 numbers are received and stored in an array. This is also a proof of the numbers being printed. We printed it in a single line using this command, the simple printf command over here. However, you can also do this for loop and try to print it. So what I'll do at this point is I'll just paste the for loop. I will print this separator line, which looks good by the way. And now here, instead of scanf, what we will do is we will printf %d. We don't need ampersand for print, and what we'll do is we'll just keep some space, or we'll just keep a new line after each number. Let's run. So now I'm giving 99, 88, 77, 66 and 55. Now you can see this is my first structure of printing, and this is my printing after applying for loop for printing the numbers. This will clarify the doubts regarding indexing and how arrays can be accessed, how arrays can be utilized with for loop. We'll do some exercises based upon it, and then we'll see the string handling or the text array handling. But first, get a clear understanding of this integer array handling. Thank you for watching this video. Hi there. Now let's look at another program or another problem statement that you can solve using array. That is about sorting numbers in an array. So what I want to do is, let me describe the problem statement once on the notepad or on our code blocks. So the problem statement goes like this. I will save this code as array underscore sorting. So what I need to do first is I need to either create or scan an array of 10 numbers. Better you scan it because it will give you another practice. So scan an array of 10 numbers. Let's call it main. Now the odd numbers of this array should be added to a new array. Let's call it odd. and even numbers to be added to another array even. So we are going to require three arrays. One is called as main, which will scan 10 numbers. Then you will do your program and you will save the odd numbers in the array called odd and the even numbers in the array called even. Again, I would say, please stop at this moment, pause this video and try to do this code all by yourself. If you don't get it, please continue with the program. But please guys, please do give it a try, okay? Experiment, or what I say, the practice is the key here. So please don't skip the practice. Now, let's see the solution. Again, I'll just break down the problem statement. So now you know it. What is the problem statement? We need to have three arrays, scan it, and then try to find out the largest and smallest out of it. So what I'll do is, I'll just take void main, then unsigned int main, let's call it a array of 10, and we don't know about the others, so let's keep them also as size of 10. It may also happen that all of the numbers are even or all of the numbers are odd. So I'll take three arrays like this. Then let's take a couple of variables, all may be used or may not be used. Now first, let's scan them all. So let's print it. Please enter 10 numbers one by one. And then what we need to do is, for I equal to 0, I less than 10, I plus plus, that is a for loop to repeat 10 times. Then scanf %d, ampersand main of I. So those 10 numbers will be stored in a variable called main. Okay. Now after this, what we need to do is, we need to sort it. Basically, we need to check every element of main. If that element is odd, then save it in a variable called even, otherwise save it in a variable called odd. Now this part is a little bit tricky. You need to create your for loop very carefully so that the numbers are stored in right index. It means even if the first two numbers are odd and the next all numbers are even, then also the even array should not start with number 2, it should start with number 0. What I mean to say is, whenever you store any value in even or odd, it should be properly stored from location 0 and onwards. Let's see how we can do that. Now to make sure that both of them actually get stored into even and odd locations rightly, what I'll do is, I will use different index for storing the numbers in even and odd. Let's call it int e is equal to 0 and int o is equal to 0, or let's call it int ev and int od. So, or let's make it simple, k m. Now how it goes, see here, printf, scanning done. Now I'll have the same for loop again. For I equal to 0, I less than 10, I plus plus, because I want to check all the 10 numbers in main of I. How do I check whether the number is odd or even? It's very simple. If main of I %2 means the mod operation. It is basically the mod operation which results in 0 if it is divisible by 2. Basically, this will do what? This will return the remainder of the division. So if main or this number mod 2 returns us with 0, it means the number is properly divisible by 2. It means it is an even number. So let me write it down like this. So if main of I mod 2 is equal to 0, what it means? This is an odd number. I'll just write it down. It means it's an even number. If it is divisible by 2, it means it's an even number. Where we need to store it? We need to store it in even. The name of variable is even. And let's put the index as k. So even of k is equal to main of I. It doesn't matter which index main of I is having. It may be 0, 1, 2, 3, whatever it can be. But the k here will start from 0. And every time we get an even number, and when we save it into this even array, what we will do is we will manually increment the index k, so that whenever the next even number is received, that will be stored in even of 1. Then k is equal to k plus 1 will make the k value 2. So when the next even number is received, it will be stored in even of 2, and so on. So this ensures that our even array starts with 0 and runs forward. If I do even of I is equal to main of I, the problem is, let's say the first number is odd, the second number is odd, the third number is even, for example. So even of 2 will be main of 2. We don't want to start even with 2, 3 or any such thing. We want to start it with 0 precisely. And if you give 0 here manually, then also there is a problem, because when the loop iterates, you will get many different numbers. You don't want to store them at the same location. So we use a completely different index for it. So even of k is equal to main of I, and k is equal to k plus 1. This will increment only when we have got one number in the 0th location, next number in first location, next number in second location, and so on. Now you got the idea. So similarly, what we do is else odd of m. We have also taken this m index, which is 0, or variable which is 0. So if the number is not even, it means the number is odd. So odd of m is equal to main of I, and then m is equal to m plus 1. Another way to write the same line is m plus plus. By the end of this for loop, what will happen? Printf sorting is done, then printf /n even array is, after /n, let's write down the even array values, and then we'll write down the odd array values. So you can print the even and odd arrays one by one. So let's print even array first. Now while doing this, the problem is we don't know the length of even array, right? We cannot create a for loop because we don't know the length, or do we? I believe we know the length, because the even array length is k and the odd array length is now m. So let's try to print it. So for I is equal to 0, I less than k, I plus plus, and printf %d, comma, even of I. Now what you are doing is, you are creating a for loop from 0 up to k. K is the length of even array. Similarly, m is the length of odd array. So odd array is I less than m, and here odd of I. So m and k are having the final values, okay? Let's say there are 5 odd numbers and 5 even numbers. So both k and m will consist of 5. And because of that, that array will be started here from 0 up to 5, and all the elements will be printed. Our program seems complete. It may have some errors. I'm not so sure about it. But let's give it a try, okay? So build and run. Okay, there is first error. I missed semicolon. I missed semicolon here also. Build and run. Enter 10 numbers one by one. Okay, let's put 10 numbers. 54, 65, 95, 87, 88, 61, 22, 50, 10, 8. Scanning is done. Even array is this: 54, 88, 22, 50, 10 and 8. An odd array is 65, 95, 87, 61. As you can see, the output is correct. The problem is we missed a new line after even array. So let's solve it. So we missed /n here. Even array is this and odd array is this. Let's give it a try again. It's interesting. Now, 65, 95, 66, 84, 12, 31, 20, 51, 43, 33. Scanning is done. Sorting is done. Even arrays 66, 84, 12, 20. Odd arrays 65, 95, 31, 51, 43 and 33. Get it? Entire numbers are there. So these are 4 numbers and these are 6 numbers. Not a single number is missed and everything is working exactly as expected. So that's about it. I hope you will enjoy this exercise. Now, once you have seen it, I would say, please try to do it on your own without looking into the solutions. Keep practicing. Thank you for watching this video.